What if we want to multiply two radicals together, but they don't have the same index? Okay, question 7 here. We've got two that don't have the same index. One's an eighth root, and one's a square root. Okay, we can handle it, but we're going to have to change them to fractional exponents first. So, power over the root there is 1/2, right? Power over the root here is 1/8. Now, if the exponent is 1/2 and 1/8, then we have to, when we're multiplying, we're going to have to add them together, right? And when we add them together, taking me back to my middle school days, maybe a little elementary school, where we got to get like denominators. That's right, folks. So your favorite thing in the whole wide world, adding fractions together. So we're multiplying the 1/2 by 4/4 to end up with this stuff right here. 4 plus 1, which is 5/8. So 3 to the 5/8. Simplify your answer, including any radicals. So they want the 8th root of 3 to the 5th, the 8th root of 3 to the 5th, which, and 3 to the 5th is 243. I'm not sure whether they will like this answer or this answer. So you might have to make sure. Use integers or fractions for any numbers in the expression. I don't know. You'll have to just see whether it takes the 8th root of 3 to the 5th or the 8th root of 243. All right, so let's see here. This is a different question because the exponents are both the same in this one, but the bases are not. That's different, but we could handle this one of two different ways. I'll show you two. The first way looks like this. First of all, notice that they're both the same exponent. I'm going to use the power of a power property in reverse. I'm going to go backwards with it. See, I know you're used to using it like this, where you push it inside to everything that's inside. Well, I can go backwards and use it. So I can take this and put it together, and now I know that 3 times 9 is 27, and we're looking for the cube root of 27, which is just plain old 3. That's the answer to this question. Now, if you wanted to go down a different road, I don't know why you would want to do this, but we could, we leave this alone. We got 3 to the 1/3. We could change this to 3 to the 2/3. Now, why would we do that? Well, that's because 3 squared is equal to 9. All right, so we could substitute that 9 with 3 squared, which would then give me 3 to the 2/3. Well, and then when you want, you can add the exponents together and get plain old 1, which is exactly what the exponent is there. So, whichever way you want, you end up with that particular answer. Two different ways to think of it. Question 9. We've got 13 to the 1/2 and 13 to the 1/3. 13 1/2, 13 1/3. Write them like that. Get common denominators. Got to multiply one of them by 3 and one of them by 2. And then add the two fractions together so we end up with 5/6. So 13 to the 5/6. Like I said, I don't know whether it's going to take this answer or whether they're going to make you actually multiply it out. 13 to the 5th is 371,293. And, I don't know which one it'll take. Hopefully it'll just take the 6th root of 13 to the 5th. Okay, question 10. We have got the same concept, but instead of starting out as radicals, they automatically have fractional exponents, which just makes the question faster. Get common denominators. So 4 plus 3 is 7/14 and 7/14. Look, that reduces. So sometimes the exponents actually reduce, and then you can simplify this to square root x. Much nicer. Question 11. Not a whole lot of difficulty with question 11, right? The 9th root of c. The 9th root of c. That's it. C to the 1st, I should say. I guess I could put it in there. I don't need to, though. There's nothing in Math Excel that will require you to write that 1 in there. But it's there. So if you just put the 9th root of c, you'll be good. Okay, question 12. We've got the powers for the root is 3. They want me to write it as a rational exponent. Remember, they're basically just saying a fractional exponent. And that's how we're getting x to the 4/3. Power on the top, root on the bottom. Okay, so when we're doing division, we will be subtracting the exponents. This will require you to get common denominators again. So first we changed it into 3/4 and 3/5, right, for the exponents, power over the root. And then we said, oh, we're dividing, so we'll subtract the exponents. Getting common denominators, 15 minus 12 all over 20, because the common denominator is 20, which is 3 over 20. And then as a radical, we would have the 20th root of w to the 3rd. You can't get it any simpler than that, unless somebody would tell me what w is. If somebody tells me what w is, I could type it on a calculator, but I don't know. Sorry, yawning. Last one of this Swyk. So, same idea. Rewrite it into its radical form, 5 to the 1/6, 5 to the 1/3. And then get common denominators because you will be subtracting them. And so we get 1/6 minus 2/6, which gives me negative 1/6 for the exponent. And so we can see that that negative. We're going to deal with that negative. How are we going to deal with it? Remember, it causes the flip. Basically pushes that to the bottom, loses the negative exponent. And then we could rewrite it as 1 over the 6th root of 5. Oops, moving my picture around here. 1 over the 6th root of 5. Notice that it says, just like the other one that had the radical in it, that I said I didn't know why it didn't have that instruction. Right here it says, do not rationalize the denominator. Okay, that's enough for this Swyk. Have a great Swyk. Is that even, can I even say that?